Hi everyone, and welcome to today's webinar, which is LimitState Fix, the best one-stop shop for 3D mesh repair. I'm Tom Pritchard, and I'm the LimitState Fix product manager and also the host for today's webinar. I'll be taking you through a few of the features that make LimitState Fix what we think is the best solution for 3D mesh repairs. We'll just go on to the contents for today's session. Firstly, I'll talk to you a little bit about LimitState Fix in general before going on to the features of the software. Then the meat of the session will be looking at examples, and then we'll wrap up with a summary, and there'll be some time at the end for a Q&A where you can ask questions at any time by entering them into the interface that should be in front of you. So I'm just going to turn off my camera and we'll go into about LimitState Fix. So what's the need for mesh repair in the first place? Watertight, error-free meshes are required in many industries for a range of downstream applications, and they may include manufacturing to fix and optimize components before they're produced on, for example, 3D printers, CNC, or injection molding machines. Similarly, you might need 3D models of jewelry designs before they're produced. Automotive and aerospace models look to design and test and manufacture and prototype. Medical and dental applications, you can model organs and other body parts for surgeries using 3D meshes, use them for prosthetics and other applications, and so on. So there's a wide range of industries that utilize 3D meshes and require them to be of good fidelity in order to use them efficiently. A lot of the time you'll find that errors will creep into a mesh file either as a result of how the original model was created. For example, if you're doing Boolean operations and they aren't executed correctly, or maybe as a result of the meshing process itself. For example, if you're meshing a complex point cloud from a scan, or if you're interpreting or creating a particularly complicated solid geometry. And fixing these errors can be a very laborious process, especially if you're doing it manually. There are, yes, a number of free applications that do promise to help you, and sometimes they can, but generally you'll find that the repair functionality that they provide is quite rudimentary and only a limited part of what the application was designed for in the first place. For example, it might be for rendering or viewing or creating animations and things like that. And this means that getting the right results from a healing can be time-consuming, or sometimes it's just impossible to achieve. There's also quite a range of paid-for applications, but again, the repair functionality can quite often be a smaller part of the overall offering, and the results aren't always the best, and you're paying a premium for it. So what's needed then is a one-stop shop, an application where the speed and the quality of the repair is put front and center, and an application that will fit into your established workflows and all of the different end users that we looked at in that previous slide. And that's where we feel that LimitState Fix comes in. So a little more about LimitState Fix itself. It provides users with a single application to take those error-filled meshes and repair them quickly, easily, and to a good standard. And how does it do this? Well, what we've done is we've taken the leading industrial strength mesh repair technology, Polygonica, and we've incorporated it into a user-friendly interface to create a powerful application that's primary purpose is to help you repair those meshes quickly. And when we've tested the results that we get out of LimitState Fix against the alternative methods and technologies, it's proven time and again to work faster and provide higher quality results than any of the other tools that we've found out there. And this is perfect if you're wanting to incorporate mesh repair into your design and manufacture workflow, and especially today's webinar is sort of going in the same direction, especially if we're looking for 3D print end users. And with that in mind, Fix version 4 incorporates a number of useful features to help make preparation for 3D printing even simpler for you, and we're going to look at some of those today. But before we take a deeper dive into that, it's worth just stepping back and saying a few words about Polygonica, the technology that underpins LimitState Fix. So Polygonica is a set of industry-leading mesh processing APIs that have been developed and distributed by MachineWorks since the early 2010s, and the libraries themselves actually go back even further than this. And what MachineWorks themselves pride themselves on is providing incredibly well considered and unique technologies for fast and robust mesh operations. And Polygonica itself is used behind the scenes by a whole host of very well-known 3D printing companies, and that includes machine manufacturers, print bureau, software providers and the like. And it's also used in many other high-value sectors, such as the ones that we spoke about previously. And again, what LimitState Fix does is to provide access to the core mesh healing functionality of Polygonica, but in an easy to use package that's accessible to users from any sector, organisation size, and it's also found a place with home users with their own desktop printers. A little bit about the features of LimitState Fix. So the bread and butter of it is the auto fix functionality, and this is a single button in the user interface that will take your error-filled mesh and perform all the operations that we have listed here to leave you with a watertight geometry that you can then pass on, for example, validation or directly to your 3D printer. It will close the solid, orient any of the normals that are out of step with the surroundings, remove self-intersections or noise shells, and it will also repair non-manifold edges before finally validating the layout in the platform volume. And more often than not, this is all you have to do. Just load in your file, click that auto repair button, wait a short while, and then save the results that come out of it. However, if you need to, you can also run each of these operations in isolation. And I spoke previously about LimitState Fix 4 and how that, in response to user feedback and with the aim of making the workflow even smoother, we added to this version a suite of functions to facilitate fixing for 3D printing and specific print platforms especially. So now what you can do is you can load in a number of objects into a predefined print platform, and as well as healing them, you can also arrange, snap, scale and validate the layout, and then export those results both as a mesh and as a slice file with specified layer thicknesses. But that's enough of the presentation. Probably the best thing to do is to jump into the software itself. And the first example that we're going to look at is quite a simple one, and it's the Stanford Bunny. And the Stanford Bunny was a 3D mesh that was created from a scan in the mid-90s at Stanford University, hence the name, and it's probably one of the most well-known 3D mesh tests that is out there. And what we've done here is we've taken that mesh, it's got about 70,000 faces, and we've just introduced a lot of errors in it in order to show how LimitState Fix works. So if I open the software, firstly a little bit about the interface. We have at the top of it here, we have all of our actions, so obviously file actions, and then model, importing, exporting, taking things out of it, and then further to the right we have the auto fix button, as I said, and then all the different manual operations. On the left hand side here we have a project tree, and on the right hand side we can see we'll have, when we've loaded it in, a list of the errors and the properties of that mesh. So the easiest thing to do is to just go to import, and we see here Stanford Bunny with errors. We'll open that, and we can see the first thing that happens is that it reads in the file and it assesses it for those errors, and it has a look and says, okay, what errors do we have in this model? It takes a few seconds, but on the right hand side now in this error tree we can see actually we've got of the order about 21,000 errors, a lot of open edges, self-intersections especially, and non-manifold edges. And if I rotate this model here, we can see actually we've got a big hole in the side of it, several holes in the bottom, and then if we zoom in a little closer we can see actually self-intersections, which are this cyan colour, and non-manifold edges, which are the yellow. On the left hand side here we can see that our file has been loaded into the tree, and if we rotate a little more, obviously these errors are all around it. In the ribbon bar you'll also see that the corresponding manual fixes that are available to be undertaken are actually highlighted, as well as this auto fix button. So the first thing we want to do is just click this auto fix, and it's going to use the default settings. It takes only a couple of seconds to complete all the actions, and we can see now, if we look on the right hand side here, we have no errors. On the left hand side, our Stanford bunny file has gone from having a pink icon to a blue icon to show that it's been fixed, and also in the output window we can see all the actions that have been taken. So we've fixed the file, but actually if we take a closer look, especially around this area here where the hole was in the first place, the results are not necessarily as good as we might want, but there's no problem there. What we can do is we can change the hole closing algorithm that we're using in order to have something that more closely matches the surroundings. So at the moment, if we undo that and go into the settings, we can see here the hole closing algorithm that we have chosen is fan, and that's quite good if we're closing large flat holes, but obviously our bunny model here is quite curved and with quite an undulating surface, and we might want to try and reproduce that more closely. So if we choose the feature smooth hole closing algorithm instead, and again just run the auto fix, after a couple more seconds again we can see that now the results over that face are a lot better for the purposes that we need it, and also on the bottom here as well. You can see the contours of the surrounding areas have been considered in a much more rigorous fashion than we had with that fan closing. So now we're happy with this model. Let's save it for print. You see all the fix options are greyed out, all the errors have gone, so we're okay. If we then click on export, we can see that we can save it as a range of different file formats, but let's just save it as an STL to start with, and we'll save it as Stanford Bunny fixed. When we come to save, we see we have a few save options. One of the things that you can do is round the solution to a certain number of decimal places, and that means that you can then read the output into other mesh software without necessarily flagging up anything, because the precision that's used within LimitState Fix is quite often a lot higher than in other software, and then when it gets read in, other software will then round it itself and show that there are errors in the mesh when actually there aren't really. It's just that they're using a lower number of decimal places in their precision. So let's keep that on, click OK, and if we then select this one with the errors, remove it, and instead import the fixed one, we can see here on the right hand side we're reading in with no errors. So it's all good. If we now jump back into the presentation, what we've seen is just how quick and powerful the auto mesh repair process is in LimitState Fix, and it's worth just looking again at the two hole closing options that we investigated. On the left hand side here we can see the fan option, and which looks to close the gap using this fan of triangles, using the minimum number possible while maintaining this edge fidelity, and as we said, this is good if you've got large flat areas to fill. However, in this case we had quite a textured and curved surface, so the features smooth option provided much better looking results, far more in keeping with the original, despite the hole being quite large in relation to the size of the model. So let's take a look now at our second example, and this time it's going to be one of multiple object fixing. So here we can see what we're going to load in is actually dental models in this particular case. So if I bring out LimitState fix again, we'll close this file, we'll click on new, and we can see here when we start a new project we get the option to have a particular workspace. Now in this case I want to make my own workspace or platform, so I'm going to click the add new and I'm going to call it new platform. Let's give it a 300 by 300 by 300 millimeter volume. The layer thickness by default is 2 millimeters. We're going to keep it at that, even though it's quite high compared to what you'd actually get on many industrial printers. The reason for that is that in a minute we're going to have a look at the slice file output, and that layer thickness will allow us to see that a bit more easily. And also a packing margin for when we're arranging the different models in the platform space, we're going to have that as 0.1 millimeters. So I'm going to click that and we can see our new platform's chosen, all the details are there, and here it is in the middle of the screen. What we need to do now is import our models. So let's go to example 2 and we can see we have 3 separate models. If we open them, the software then imports them into that space, and then once they're all there it looks to arrange them. So let's say best fit, and we want to focus on the bottom left. Click OK and we can see here that everything has been then moved to the bottom left of that space. And what we can do is we can select each of the different files in the tree on the left hand side here, and you can see in the errors tree on the right hand side the numbers change according to which one it is. If we take the dental implant large STL file in itself and zoom into it a little more, we can see there's only 8 errors in it, and it may be a little difficult from a distance to see where those errors are in particular. So let's choose an open edge. What we can do is look in this tree here. If we select the different errors, so 1 out of 4 here, we can see actually that there's a yellow arrow there which very helpfully shows us where the error is in this particular STL file. And we can see here it's an open edge, and actually we would need to close the solids because it's got a green line on it in order to fix that. So if you're not quite sure where the errors are in your model, you can always come along and click any of these in the right hand side to see them on screen. And if we look again at the project tree, what we can do is actually we can fix each of these individually. If we have them selected, you can see the auto fix and the manual fixing options that are relevant are always highlighted here, but also we can select the top level and click auto fix, and then the software will go through and fix all 3 of them simultaneously. And this process takes about maybe 20 seconds. We can see at the bottom here what's going on. So at the moment it's closing the solid, it's actually using the fan algorithm, and on the right hand side here at the bottom there's a little progress bar that shows how far through that process we are. So now it's on the deleting self intersections slide, and what's happening is it's effectively following that list of different actions that we went through on the previous slide in the presentation. And once everything gets fixed, on the left hand side here, as we discussed earlier, those pink icons will turn blue as they've just done, and if we select the individual STL files, we can see on the right hand side that there are no errors and the number of shells for each of them is 1. One thing that's interesting is we can see that each of these has orange borders. If we click the validate button, then we can see actually those borders have now turned green, and that signifies that everything is okay with them. So there's no clashes with either the other models within the platform space or with the edge of the platform itself. If we right click the top level of the project, we can see that there are a few different options available. We can export individually, and we can convert to parts. And as you may imagine, export will export everything in the same file. If we export individually, each object will be sent out to a separate file, and convert to parts will take any separate shells in the whole project and save them as different files, which is useful if you get a file from a client where everything is contained and counted as a single solid, and we'll touch on that shortly. But for now, we're going to export everything together, and we'll export it as a slice file. You can see we've already got one there, but I'm going to call this dental parts fixed. Just delete that there and save it. And then what you can do once you have your slice file is that you can open it in software that will read a slice file, such as Rhino that I've got here. Let's have a look. So dental parts fixed. If we open that, we can see here that we have our different layers with the different slices for our 3 different components. And obviously, as I mentioned earlier, the distance that we set between the slices in this case was 2 millimeters, but that was mainly just to be able to show in this here. If you're actually exporting for actual construction, then you might want to have that value a lot lower. So we've had a look at a basic problem, we've had a look at a problem with multiple parts in one build volume. The next thing we're going to do is look at converting a single model to parts, as we touched on just now. And in this particular case, we're going to be looking at mechanical parts. And if we open the software again, we'll just close this, don't need to save it. So we'll start a new project, and again we need to set up the workspace. In this particular case, we'll look at having an Arcam A2 wide platform. You can see here the layer thickness is much lower. We'll click OK, and here is our platform. So now if we come to import, we'll import one single file, which is our mechanical parts with the errors in them. And the first thing you'll see that happens is that the software does a bit of a sense check, and it says, okay, this thing you've imported appears quite large. Are the units that you're using correct? And it tells you what the dimensions are, and also what the units are in the software, in the file at present, and you can scale it if you want. But we're happy with this. We know that it's the correct scale. So if we click OK, we can see that it's read in our file. We have one entry in the project tree on the left hand side here, and we have approaching 500 different errors within the 3 different components that we have. And indeed we can see actually the 10 shells because of these errors, whereas we actually only have 3 components, so we know that there's something wrong there. The different components, just for interest's sake, we have an end of arm tool here on the left hand side. We have a component for a satellite mount, which is this small cuboidal one here, and we have another cylindrical component, which is, I believe, either a sensor to go on the side of a satellite or maybe an aircraft at the back corner. So again, what we'll do first off is auto fix, and the software will take a few seconds to go through and close the solids, reorient the normals, make it manifold, etc. And then once it's done that, on the left hand side here, it will turn into a blue icon. So yeah, we can see here it took about 20 seconds, and we can click the validate button, it will say it could not perform clash detection because there's only one object, but we know that it's within that build volume. So the next thing we want to do is actually convert that to parts to see that the original model here is replaced by 3 components. So we go into the project tree, right click, click on convert to parts, and it will ask, are you sure? Because you can't undo this once you've converted 1 into 3. We'll click yes because we're happy for it to do that. And what happens is it will go through and separate out each of the 3 different components. Again, it says it couldn't perform clash detection because they weren't clashing, but they're all within our RCAM build volume. If we then go to the top level and export individually, you can see actually I've already done it previously, but let's say again for this, got LimitState fix 4, save, we have our save options dialog, we'll click OK. And then if we close after this, what we can do is we'll do a new one, RCAM way too wide again. And if we come back, we can see here we have our 3 models that we can then open into this build volume. The final thing that we can do is that once we've loaded these models in, we can, for instance, select our satellite mount component. If I move that over here, just to show you some of the other functionality that we have as part of the 3D printing suite, is that I've moved this into the air. What we can do is we can snap that to the base, which is done. We can also scale it. So let's say we want to make it twice as large. We can scale it accordingly. Similarly, we can simplify the mesh. So at the moment it's got about 30,000 triangles. If we wanted to say halve it to 15,000, we can do that. We can limit the error on the triangles that are created as part of the simplification. Click apply, and then we can see here that we now have 15,000 faces as requested. There are a few self-intersections, but again it's a simple task just to click the auto heal and everything's good. And finally we can validate it. Now everything's green and everything's okay. So if we move back to the presentation, just to summarize quite quickly, so it's a brief look at the functionality and power of LimitState Fix, and it's a tool that we believe to be the best one-stop shop for mesh repair. And you'll have seen that it repairs 3D mesh files quickly and robustly, that there's no need to undertake laborious manual fixing because the auto fix functionality will do a best first guess repair for you. There are a range of features that are designed to integrate into the 3D design and print workflow. You can repair multiple objects and export them, and you can also output as a fixed mesh or in slice file format. So we have a minute or so just for any questions that people may have, so if you do have any that you're wanting to ask, do feel free to enter them into the Q&A box now. Okay, so the first question is, what file formats can you work with? So you'll have seen through it that you can work with STL and ANMF, which are far and away the most popular formats for prototyping, CAM, 3D printing, etc. You can also export these formats and also to a slice file or CLI. The second question is, how do I get hold of a trial? Well, it's a good question. If you visit LimitState.com/fix, you can download a copy. It has all the features available, but save and export will require you to have a license. And you can also obtain one of those from the same website. Lastly, will there be a recording of this webinar? Yes, we'll make recordings available in the next day or so, and we'll tell everybody when that's available. That will be on our YouTube channel, which is LimitState Software. So without further delay, that's the end of the presentation. We do hope that you will join us again for one of our future webinars, and we hope to see you there. Goodbye.